All right, let's get right into this explainer. We are unpacking the massive data rivalry dominating 2026 and how these two absolute giants are rapidly evolving. If you're an enterprise data leader evaluating your tech stack right now, well, you already know the lines between data warehouses and data lakes are blurring faster than ever. So today, we're going to break down the current state of Databricks and Snowflake. We'll look strictly at their latest architectures, their new 2026 release notes, and the real-world operational trade-offs you have to consider.
Here is our roadmap for the explainer. First, Snowflake versus Databricks in 2026. Then, Lakehouse versus Data Warehouse. 3. Embracing open source and Iceberg. 4. Powering up Cortex AI. 5. Building Snowflake native apps. And 6. Choosing your data strategy. Let's jump in.
Section 1. Snowflake versus Databricks in 2026. When you get right down to it, it's really a clash of baseline philosophies. It literally pits Databricks' engineering-heavy focus directly against Snowflake's analyst-friendly design. Databricks is built on Apache Spark. It's inherently code-first, designed for massive scale-out processing, streaming, and heavy AI workloads. So you've really got to know your way around Python, Scala, or SQL. Snowflake, on the flip side, was built from the ground up to be a cloud-native data warehouse that prioritizes SQL-first workflows. It's laser-focused on business intelligence, ad hoc analytics, and basically getting analysts productive from day one with almost zero operational complexity.
Section 2. Lakehouse versus Data Warehouse.
Databricks leans heavily into this lakehouse model to unify all sorts of diverse data types. It stores your data in open formats, think Parquet and Delta Lake, on object storage that you actually control, and then applies transactional reliability right on top of that. It's absolutely fantastic for machine learning and messy, unstructured data. Now, Snowflake historically took a different route. They championed a multi-cluster shared data architecture. They strictly separated compute and storage to deliver incredibly consistent, lightning-fast SQL queries for concurrent users, while completely managing that storage layer internally.
Now, what's really fascinating here is the pricing and performance trade-off, because it dictates where each platform gives you the best bang for your buck. Databricks charges based on DBUs, Databricks units, which separates out your infrastructure costs. This means you can use lower-cost spot instances for those massive ETL jobs, saving a ton of money. Snowflake, meanwhile, uses a credit-based consumption model. It is incredibly simple to forecast, which means far fewer surprises for your CFO. And it scales automatically. So if your default workload is high concurrency dashboards, Snowflake is highly cost-effective. But if you're doing massive, heavy-duty data processing, Databricks usually takes the lead.
Section 3. Embracing open source and Iceberg.
For the longest time, the big knock against Snowflake was vendor lock-in with its proprietary closed storage, but they are actively changing the narrative. Snowflake is bridging the gap by rolling out Snowflake Managed Storage for Iceberg tables, and they're allowing read and write support from external query engines like Apache Spark. They are essentially telling the market, hey, you can have our incredibly fast SQL compute, but go ahead and keep your data in an open format. It's a huge shift.
And they're moving fast. With their May 2026 support for Iceberg version 3 and the brand new Polaris 1.5 catalog updates in June, Snowflake is proving they can handle highly complex, format-agnostic infrastructure just as well as Databricks. They've added support for geometry data types and deletion vectors to drastically speed up updates. Even more impressively, with Polaris 1.5, they made authorization pluggable. They now support Apache Ranger, meaning enterprise teams don't have to scrap and rewrite their existing security policies. They even threw in BigQuery Metastore Federation for good measure.
Section 4. Powering up Cortex AI.
Look, we all know cost is a massive bottleneck for AI adoption. To combat this, Snowflake just announced a planned price reduction of up to 60% for Cortex AI Transcribe. That is huge. It makes audio and video analysis incredibly cost-effective to run natively right inside your warehouse.
The feature list here is seriously impressive. These updates allow your teams to pull brand sentiment and compliance insights out of unstructured data without ever moving the data out of Snowflake. They've integrated Gemini 3.5 Flash for lightning-fast multimodal analysis. They launched AI_Classify to automatically categorize PDFs and CSVs to handle intelligent document routing. And with the new Cortex AI Function Studio, your teams can automate prompt engineering and model selection entirely inside the platform. It's a massive leap forward for bringing AI directly to the analyst.
Section 5. Building Snowflake native apps.
This might honestly be Snowflake's ultimate trump card in the platform wars, turning into a full-fledged application ecosystem.
Instead of moving data out to an external application, which is literally how we've done things for decades, native apps use Snowflake's core features to bring the app directly to the data. Using things like Snowpark, stored procedures, and user-defined functions, it's basically an app store built right into your data warehouse.
We really need to pause and highlight why this matters. If you've ever been trapped in a 6-month security review trying to get a data transfer approved, you know exactly why this is a game changer. The architecture removes the massive compliance and security risks associated with moving data. The app just runs on the consumer's existing Snowflake compute resources. The provider gets to protect their IP by packaging the logic securely, and the consumer gets to run powerful applications without ever copying, moving, or exposing their highly sensitive data to a third party.
And the developer experience is remarkably clean. It's basically a 5-step journey to package your logic, slap on a Streamlit user interface, and monetize it globally. You just initialize the project with a Snowflake CLI. Then, you configure your manifest and setup scripts to lock down roles and schemas. Next, you write your core logic using Python UDFs or Snowpark, and you build a highly interactive Streamlit UI on top of that. Finally, you version the app and publish it to the marketplace. It completely streamlines the software distribution model for data products.
Section 6. Choosing your data strategy.
So, brass tacks. Bringing all this competitive analysis together, how do you actually pick your path forward in 2026? The rule of thumb here is simple. Don't let cool, shiny features dictate your architecture. Let your default workloads make the choice.
Take a hard look at your inputs. If your day-to-day work involves wrestling with messy, unstructured data pipelines, and you have a team of Python and Spark engineers, Databricks is your absolute powerhouse. But if your main goal is serving tightly governed dashboards to hundreds of concurrent business users, and your team's primary language is SQL, Snowflake is going to bring the speed. It delivers predictable performance and an incredibly fast time to value.
Latent View Analytics hit the nail on the head with this concept. Migrate workloads, not platforms. Because let's be real, migrating an entire platform is a headache absolutely no one wants. The most effective 2026 architectures are hybrid. A very common, highly effective pattern right now is letting Databricks handle the heavy lifting, the ingestion, the heavy data engineering, and the complex ML training, while leveraging Snowflake as that pristine serving layer for governed analytics, high concurrency dashboards, and native app distribution.
As these two giants keep evolving, with Snowflake diving into open table formats like Iceberg and deploying Cortex AI, and Databricks constantly refining its lakehouse engine, the lines between data lakes and warehouses are completely vanishing. So the ultimate question isn't really which tool is better anymore. It's what exactly are you trying to build tomorrow, and which platform gets out of your way the fastest? Something to think about as you plan your roadmap. Keep evaluating, keep learning, and I'll see you in the next explainer.